I don't work for AWS, so I can say what I would like. Okay, I'm a member of a group called AWS Heroes, which AWS appointed. But from my perspective, it was just because I was complaining too much. I was saying a lot of things on Twitter, bad things about AWS. So if they want to shut us down, they promote you to something called AWS Hero, and they pay you once a year a trip to Vegas and stuff like that. You get some inside information and blah blah blah. But in general, we just say whatever we like, and that's gonna happen tonight. Okay. So I'm gonna talk about DevOps with relational databases in AWS cloud, and in general, but what I see that AWS is really trying to solve this problem, but it's not possible to solve this problem. So it's hard because they're just it's kind of experimenting in many different ways, but you cannot scale relational databases in the cloud. Why? You can try, but you cannot succeed. You cannot succeed because they are not created to be distributed in that way that's native in the cloud. What we call native, for example, in AWS is DynamoDB, which is a database which doesn't have all these things which we used to have in relational databases, like transactions, and they don't feel natural in this environment. There's always a notion of eventual consistency and stuff like that, which is fine, because if you look at your likes or something on Facebook or Twitter or whatever, who cares if it's 15 or 16 or 20 or something, But when it's about money, it's a bit more different, When I look at my e-banking on my local bank here in Belgrade, I don't really understand why on one page I have one amount, on another page I have another amount, but at the end, I don't lose money. So whatever happens in their system, eventually it's going to be consistent, It doesn't have to be in every moment. So if you look at the cloud and what you want to achieve, maybe you should just give up on having everything so strict, okay? And then you will feel more comfortable in the cloud. But 90% of applications are written to use relational databases. We all have SQL classes in our schools. Everyone is ready for SQL databases, and SQL is so good. It's so hard to use DynamoDB in the end. SQL is great. You can easily make enormous joins, stuff like that, and you can use SQL with something called row-based databases and also columnar-based databases, which are BI databases which you can use to get some extremely complex aggregations and stuff like that. So SQL is great, and we don't want to stop using it. Okay, so we have a problem. If we want to scale too much, we may get into problems, like how to get a transactionally tight system, and then to have it distributed on many computers, different regions. Many things have to work really tight, and that's not possible. Let me give you just a couple of information on how databases work before we just go back and try to explain what AWS did. So the problem, the database, relational databases are a complex system, and the system has compute, which you use when you do a SQL query. You need something that will analyze your query, check where's my data, and then decide on what to do with that data. Okay. And also when you get that data, if you're doing some joins in the database, you need to go through different loops and then match data and do some stuff and then get the output. So there is a compute. You have to do something with the data. Okay. You have to prepare the query and then do something with the data. And then there is storage. There are many layers of storage. First layer is RAM memory that you have in your computer, which is very expensive, which is limited. And then you have very cheap storage on disk. But storage on disk is slow. If you want to do something really fast now, you need to find a way to match these two layers, okay? When you need something from disk, you need to remove something from memory and ask for a page from disk to be put in the memory so you can deliver it to a client. Okay, so if you need many things, you don't have enough space here in memory, so something has to wait for this information to be delivered. Okay? If you have Dynamo, then you have millions of servers, millions of small buffers, so they can be delivered in parallel. Here you are limited. You are limited what you provisioned. Okay, so it's not easy. If you have only 4 pages in memory, you can use only 4 pages. So it's more complicated. The process of going to disk, going to memory, going back and forth, because it's just, you have to remove something to add something, remove something to add something. It has to be smart. What AWS is doing, AWS is allowing you to install your own servers as you wish. You can you can set up your own machine, which is called EC2 in AWS, and then you put your Postgre or MySQL on that machine. And then you do it by yourself. You have storage, which can be local on that machine, but you shouldn't do that. You should use a network storage, which is super fast. Super fast. So if you really want to, if you know what you're doing, you can install a SQL server of different kinds on your own EC2 machine, and you can be really happy. That should be enough in 99% cases, so that's totally fine. You have a WordPress website, you're fine. Why you are fine? Because in most cases, what you're worried about is your storage. You're worried that you're going to lose what's in the disk, okay? The other problem which can fail is CPU. Who cares for a WordPress website? It will, if it goes down, it will start again, and then in a couple of seconds the website will be there. So the storage is something that you, in most cases, you are worried about. Okay, that's the first way of deploying application. The second way is called RDS. I mean, this is all relational databases service, but there are like kind of 2 kinds, like a normal RDS and then something called Aurora. In RDS, you can install MySQL, MS SQL, Oracle, blah, 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 different services, which is like the next step of management done by AWS. So you don't install your own machine. You don't have an EC2 instance. You don't go directly to that machine and do something. You don't have a console to do something. Although there is something now that allows you to get some access to some Oracle or MS SQL machines, so you can install some plugins, blah, 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 but you shouldn't do that. That's the first way on the left side. You install your own machine by using the service. What does service provide? It provides you with the ability to say, okay, I want my SQL server with 2 CPUs, and that's it. Oh no, maybe I need something called replication server, okay? Which is like another server which takes data from the first server and like allows you to read data from that instance. How does it do it? Like that synchronous replication is done using network, but regular network, like from a higher layer of TCP to a higher layer of TCP. So it means that Postgre database is communicating with another Postgre database, okay? So which means it's kind of slow. Imagine like 2 disks. If 2 disks can communicate on a disk layer, it could be really faster. Through the network, these 2 servers communicate, and then if there's one insert command on the first server, it has to be repeated on another one. So there is a replication lag, because you need to transfer the command and then execute it on another server. If you need extra capacity to read, like you have a WordPress website, which is really successful, you only need 1 server to write your post. But if you have millions of readers, if you add extra replicas, it will mean that you can have extra compute and extra storage, and you can access the same data on these servers. So you add extra readers, and then you put some proxy in front of it, and then they will just reroute to different readers, and then you get million requests per second, for example. Okay, if your server can only get 100,000, with 10 servers you get million, and then you're fine. It's one way to replicate horizontally. If you want to scale vertically, that would mean that if my server is not strong enough to do the compute, or it doesn't have enough memory, like these 4 pages in the memory, you need extra pages in the memory. If 2 people are doing different queries with different data, then one query can pull one set of data and remove some extra data from the buffer. And if some other person is wanting some other data, it will remove the first stack. So if you have different queries on the same buffer, it will not be enough. So you need extra memory to hold the data in memory so you can deliver your page, okay? So if you want to scale vertically, in DevOps, you usually don't have ability to add CPU, to add memory, okay? In DevOps, you would usually start another machine with a higher capacity, and then when it's ready, you can copy data to another machine and then start serving from another machine. Or you can like add a replica, which will read data. When it's ready, you can just switch to replica and say, okay, now the replica is a master, and that's it. So the way to scale vertically is done by adding capacity and then switching to another one. That's what you do with, like, if in DevOps you are scaling EC2 instances. You add another machine and do the scaling. You know, you cannot just say, oh, I want like extra 32 gigabytes, something. So before I switch to something called Serverless Aurora V2, which does that thing in place scaling, I'll give you a short intro to what's Aurora. Amazon was the first to do this thing. They created really fast storage layer. They took the code from MySQL or Postgre, removed the storage layer, which was using local disk, and said, okay, so every call I have now to disk, to get that page from disk or something, I'm gonna send it to this storage layer. The good thing with MySQL had that capability of that plugging storage layer like for 25 years, but no one was using that in that way. You know, no one changed the code. So what you see here is these storage nodes. These are not disks. These are actually machines, okay? So when you save something to disk, one page from memory to disk, you send a network call to Amazon storage to 6 different locations. And then when you have a consensus that enough of these are saved, you can acknowledge this and then continue with your operation, okay? I don't want to talk too much about the consensus system now, but in general, when you write something to Aurora's storage layer, it's done in 6 different locations in 3 different data centers. So this is very safe. Just short notice that there is something called databases on Kubernetes now. That's something that is also like a movement that people trying to achieve something in Kubernetes to start servers and to manage them in this similar way, okay? And now there are some companies trying to simulate what Amazon did with the storage layer, just to replace the storage layer in Kubernetes as nodes. So maybe one day, you know, maybe you could simulate the whole thing by yourself. What this thing achieved, you know, also, it's that replication is done via storage layer. So what you get now is, instead of like seconds, minutes, hours of replication lag sometimes, you can get like 10 milliseconds of replication lag, which is, you cannot simulate that. You cannot do that by yourself. That was a huge thing that changed how I perceived. I stopped being a database administrator completely with Aurora. I don't do that anymore. I don't install MySQL anymore. So replication lag is so small that you can forget about managing your own replicas and stuff, okay? And just to say that also what we do now in our company is that we also do everything through CDK, and we deploy stuff through also databases through CDK. You know, so everything you do in AWS can be done through infrastructure as a code. What AWS did, a couple of years ago, they created something called Aurora Serverless V1. That was exactly what I was talking about before. You don't really have to say, I want an instance with 62 gigabytes. You could say, I need an instance that would scale with my queries, okay? So they provided us with a solution that you have a pool of like a proxy layer, something, you know, and then if there's a lot of queries, they would start another server, copy the buffer to another server, and then you get a bigger instance. So this diagram shows, this red one shows the level of queries. And then the blue one shows how the CPUs and memory is changing. So it takes time for new instance to start. It takes time for new research to start and then data to be copied to a new instance. But then you get a new instance. And then when you have less queries, less need for capacity, it goes down. But it cannot follow you that fast. You see how gradually it goes down, you know, but your queries are going down right now. Just because the user that you just had on your website is not there for 5 minutes. It's just because he's making coffee, you know, he's coming back. It's dangerous to remove all your data just like that, you know, have to slow down with going down, you know. Whatever you do with DevOps, it should be in general a good policy to slow down. Going up, it's not easy also. Because if you're doing some transaction, you have some locks, you know, and you want to switch to another machine. So that means killing the query. So you should write your code in a way that it can kill a query and start again. If something is wrong, you can start again. You can try again. You know, if you have a queue, it will start again. So it doesn't matter if one query is down, you know, but it's not always easy to do that, you know. So if you have 5-10 minutes long queries, you can lock the process. And the serverless Aurora v1 had that configuration that says, okay, we will try to scale up for 5-10 minutes or something, 15 minutes, and then we will give up because we don't want to harm you, you know. So sometimes you are not able to scale up. They failed with this v1 because this product is used now only in development and for some specific usage. For example, you don't have replicas in this thing. You just only one instance, you know, so that doesn't work, you know, for many reasons. I would say that it failed what they promised. I can say that because one manager was trying to sell it, the idea of it to me. I was complaining about something else, and he was trying to sell me the idea that this will fix everything. It didn't just, it failed. So one of the proofs that they don't have enough money and resources is that like year and a half ago, they announced serverless v2. So from the announcement, the product was in preview for a year and a half. I mean, that's a disappointment because everyone was trying, everyone wants to try this and try to replace some of the stuff, you know, in the system. And then with AWS, if you buy capacity for 3 years in advance or something, you get 70% discounts. And if you postpone this idea of, okay, I'm gonna wait for this, I'm not gonna buy this now, so you're just losing money, okay? So I waited for 6 months and then I said, okay, I'm going to renew this. I cannot wait for these guys anymore. But at the end, we got the product. Product is, like in technical terms, just great, amazing, you know. So that red line and that blue line, they meet. You cannot tune it at the moment, but if your requests go up, it will immediately go up. So let me explain what they do. They have a pool of CPU processors, CPUs. Amazon bought something called Annapurna Labs, which is producing ARM CPUs, and they're really successful with that. So they have plenty of CPUs now, obviously. So they have a pool of CPUs. If you have a query, it goes to one CPU. If you have another query, it will probably go to the same one. But if the CPU is used too much, they will say, okay, we'll give this guy another CPU for another query. So next query goes to the second CPU. So they will just give you one more CPU from the pool. You'll get the CPU, okay? So it's good because, you know, CPU takes some, one query takes some time, you know, and to finish. So maybe you're still waiting for something or processing something, and then you need another CPU to do something really quick now, okay? So that's good. Another thing is that they also provide you with the, you know, with the memory. So from a large pool of memory, you get some extra 2 gigabytes, okay? So they actually made these steps smaller, okay? But with every step, they give you more CPU and more memory, okay? And line goes up just like that. So whatever you do, it immediately goes up. These are the numbers, you know, like they have something called Aurora Capacity Unit, which has memory and CPU. This is something that is not done by anyone in the market now. There's no similar product that can scale like this. When you provision the server, you say, I need minimum of this CPU and I need maximum of this CPU. You're not charged for saying, I need like 260 gigabytes or something. Even if you don't need it, you know, you're not charged for that, okay? You're charged only for what you use. Just that area below the red line in the chart. The only problem now with the product is that it's just too expensive. Like, so the problem is that the area below the red line is, that's what you pay for, So there's a lot of white area above it, If you provision a capacity, if you provision a server with like 64 gigabytes of RAM and use only 1 gigabyte, you are paying 64 times more than you need, okay? But then the product is 4 times expensive more than Aurora. So it means like you are actually paying for equivalent of 4, okay? But then if you buy Aurora for 3 years in advance, in fact, you don't have to pay for 3 years in advance. You just have to commit for 3 years in advance, okay? You get 65% discount, and you have a really huge machine for some money, and then in some terms it can, in this mathematics, like it can be really expensive. So you need to use it smart. Okay, so for what kind of workload you should use these things? For example, you have one machine which is accepting write requests, okay? But you have different machines doing different read requests. It's great to have different workloads that have like some regular patterns. For example, you have one server which is generating reports only, okay? So when someone clicks on to generate a report, you direct all the reports to that instance. Don't forget, V2 is a part of whole Aurora family. It has a couple of milliseconds, 10 milliseconds replica lag. So you can run any report like with the real data from that replica. Once you start the report, it will automatically scale to the need of that report. It will go down when the query ends. So you only pay for that one report. That's it. You have to pay 40 euros for every instance, 40 euros per month, because it cannot scale to 0. Okay, you still have to have at least some half of a CPU committed. Okay, but if you split your workload on these different kind of machines, okay, you see, for example, if you have one of like 10 tenants, 10 companies working on your software as a service solution, okay, maybe one is noisy, maybe one is making problems, So put that one, all reads, redirect all reads for that particular tenant to that one instance. That one will scale separately from others, So in that kind of scenario, you can really pay for what you need, okay? The rest of the people will just use what capacity they need. That one will scale, and maybe you can charge that client for the usage, for that particular usage. Good thing about Aurora serverless is that it automatically grows. Everything is super fast, so that's something you shouldn't be worried about. The problem, of course, is how buffers scale down. That story that I was telling, it should be slow. It shouldn't be that slow, it should be smart. Which resources are not used? Also, it's not easy to decide, okay, I'm going down. What data should I just kill and remove from my buffer? Okay, so it has to be smart to decide on that. That policy is not bad. I tried that in production. But of course, if you're not doing anything for a couple of minutes, it should go down. Okay, doesn't really matter what was there. It works with MySQL, and it also works with Postgre. I'm not really a big fan of Postgre. Postgre didn't have this capacity to. You were not able to change stuff in memory. You usually have to restart Postgre for many things, and this thing for like scaling the buffer was not available in Postgre, or maybe AWS introduced it. I'm not sure, but it's something really, really quite new. What good things you can also do? That storage layer that AWS has doesn't just end with the one region. If you want to have a replica in another region of your relational server, you can do it in a way that you start the replication in a way that it's done through MySQL or Postgre ways, okay? By shipping log files and stuff like that. But it will just take more time, to get there and be processed again on another machine. Don't forget, every query has to be executed on another machine. Why shouldn't we just change the database on the storage layer? Okay, so the good thing is that when AWS is doing that for you on storage layer, it can also do that cross-region. So there's an option in AWS to have a cross-region replica in another region and data will be shipped through a data layer, okay? So if you need something to be there if, for example, you're doing stuff in Germany and then you have stuff in Ireland, you want to have a backup in Ireland, just set up an Aurora Serverless V2 instance in Ireland that will wait for you. If something happens, it will be there. Data will be replicated, and if for some reason you fail in Germany, you will redirect your queries to Ireland, and it will automatically scale and do what you want. You will not fail if you try to scale to Ireland, because it could be really dangerous if you just switch something. Many things are available now because of this thing, and you pay only 40 euros for that. Minimum capacity you have to say is that one. Serverless V1 version, had the ability to scale down to 0. It is called pause the server. For example, if you're using a WordPress server and no one is using the WordPress server for 5 minutes, it can go down. And if the next visitor that comes to the website would need to wait for 30 seconds, for example, for that instance to start. But after that, it's fine. That would be really great to have that V2. It can go down, so you will only pay for storage. So WordPress websites would pay 0 for database, only for storage. So that would be perfect, for WordPress. Also, it depends on how do you value 40 euros. Is it a lot of money or not? The problem is, when you do DevOps, you have to do a lot of small things. If you, for example, have a staging environment, testing environment, production environment per developer, blah, 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 why would you pay 40 euros for every single instance of these environments? So that's something that we need. For these environments, I would suggest using Serverless V1. Who cares? With CDK, you can easily say, when you're deploying in production, deploy V2. When you're doing, of course, it's a different stack. It's a different database, stuff like that. But you can easily say the same thing, just for developers and all others, just use this version which can scale down to 0 and you don't pay anything. It's serverless in a way that you don't have to say, I need 10 CPUs, 64 gigabytes, and I have to pay for that for a long time. It's serverless in a way that it will just scale up and down with your needs. If you have bad query, you need to fix it. Otherwise, you will pay for it. Okay? So that's also with Lambda. If you have really bad Lambda, you will pay a lot of money for that. So you have to really, but you will see that with this. If you pay 64 gigabytes of RAM and 10 CPUs, you don't care what you're doing in your system. You don't care why queries are slow. Oh, we all know that when someone starts reports, query system is slow, we don't care, But that's because we have a fixed budget, and it works. We adjusted ourselves to that money, okay? So, yeah, it's serverless in a way that it will help you scale up and down, but not in all these terms. This is how serverless looks to me, like many events coming to something which is not ready to accept that, like you have a database which can accept only 500 queries per second or something. And then you can have millions of events coming in parallel at the same time. So you need something to stop that. You can fix some of the things with the proxy, but why don't you just deliver all requests, So if you scale up, maybe you can deliver, So yeah, you have to do all the techniques, but with serverless it's much harder, with the connection pools and proxy servers, with standard implementations, you kind of know how many connections you would get at the end, But here, you can have millions of queries per second, and that's also already a lot. You can join also our user group. My user group is AWS user group, but we also have a Slack channel. We have discussions. We have a lot of online stuff in the last 2 years. Previously, we did a lot of meetups, and we also had a month ago. We had a very good discussion about Serverless V2. So with a lot more bad jokes about AWS. So I hope you didn't mind. Okay, guys, that's it. Thanks.
I remember one solid example where you said, okay, this is, from your experience, really good choice where you're thinking, should I employ Serverless 2.0, which is, you have clear, batch processing, use a lot of usage data, then just scale up, scale down. It's much easier, more convenient, and
and cheaper.
Cheaper. And for average user, it's like win-win. Do you have some other examples, like like from your experience, like when it is good choice? Just
Yeah. Okay. So there are many products that try to scale horizontally in different ways. Okay. So for example, Microsoft acquired Cyrus, which is a Postgres solution, but there's also, like, for years, great solution for MySQL called Vitess, which does these solutions tend to solve one problem, which is like if you have a software as a service company that has many clients, and then you keep all the clients in one table, and then you have one column called company ID, for example. And then if you have queries in such a solution, 99% of the queries will have where company ID is that, okay? So what these solutions were trying to solve is that let's do something called sharding and say this and this and this company will go to this shard, and this will go to this shard, and this one is super noisy, we'll have a special shard for this one. So you can have data on many different servers at the same, like 5 servers can represent one shard, okay? Servers doesn't mean that is not the same thing as a shard, but let's say, for example, that one shard is one server, okay? So noisy neighbors are a big problem. So if you have one client which is big and another one is small, you don't want to charge them the same amount of money, okay? Maybe you would charge, but then this noisy one is actually, you want to charge them more, okay? So how do you do that? Like make special shard, and that shard does the whole thing. So with Vitess and Cyrus, you would provision one shard, one server. That one will be 64 gigs. Another one will, all other shards will be like 4 gigs. Okay. So you need to set up let's say, fixed environment. Okay, which will scale in a similar way that I said with the V1. You need to start another instance, and then it will switch to that one. Okay, so scaling up is not easy. So imagine having that one. So you have, with Aurora Serverless, you can set up 15 different replica servers, okay? So you can set up a system where one of these replicas will represent that one noisy neighbor, okay? So maybe you can have 3 servers for that one, okay? The thing is, that one also doesn't have the pattern that works 24/7. During the night, they are down. During the day, they are up, So who knows all the patterns, So it's hard to detect all the patterns. So Serverless V2 is more expensive because they guarantee you that they will scale for you. They will be there for you when you need it, So you have to pay for that. That's obvious. You don't get anything for free.
But they promise the 30% cost reduction.
Wow, it's yeah. I get 90% cost reduction on some things with Serverless V2. So the sharding problem is not an easy thing. So but with Vitess and Cyrus, you get shards which can write. They can deliver. They can handle writes only. Also, So different shards for writes also, not for read only. Okay. So what AWS is missing is real sharding solution for horizontal scaling. We need that. Okay. I would say that Microsoft has something great with their MS SQL. Their SQL server cannot, but the cloud server, it can scale. It can have a shard that can scale, separately, So I'm not really deep in that. So in Azure stack, I run away from that always. So, but they have some good solutions for that, So that's something which is missing, But if you ask me why I want to do that, noisy neighbor, that's the first thing, and then reports, batches, and stuff like that. So everything that is unpredictable is super great.
There's another trap that you can fall into because it's called serverless. You may think that it's a good fit with Lambda functions, but serverless stack, and it's not. It's just,
I don't agree.
Yeah.
We do that, you know. So the only thing is the cost. You know, Lambda function doesn't cost you anything if you don't use it. This thing costs $40, 40 euros. So that's a problem. Okay, yes?
About the storage layer that you mentioned, that changed. Can you explain what's the new way of? I didn't see it on the slides.
No, storage layer for Aurora Serverless v2 is the same one as the original Aurora. You know, Serverless v1, that's something different, you know. Okay, but the Aurora storage and the v2 is the same. The good thing is you can mix now these auto-scaling servers with the regular server. You can have a cluster where one machine is 64 gigabytes all the time. Another one can scale up and down. Another one is like a small machine. So you can have a mix of these things using the same storage layer. You know, so you write something on one machine, it goes down to the storage layer. If one server doesn't need data, it will not read it. It will not execute it. The difference between the Postgre and MySQL replication and this is that every replication means executing the same command on another server. So if you have you do alter table on a master, so all replicas need to do alter table. You know, with this, only master will do the alter table. All others will have this image of a copy of the system at the same moment. You know, the thing is committed. So that's amazing. You know, that's why it's faster in any way. So other servers, they don't need to read data to memory if they don't need it. See, that's a huge thing. You have much less IOPS and you have to pay for IO. There is another product called Alloy something DB in Google Cloud, announced like a week ago. They sell it like this IOPS is free. I mean, that's crazy. Someone has to pay for that, you know. In AWS, you have to pay. That's what I love with AWS, you know. So you are charged for the things you use, so you have to think about that. Otherwise, they're gonna charge you like something.
Every second row will be Google Ad.
Yeah. So. Okay, guys. Thanks. Thank you. Recording stopped.